preparing data for deep learning neural networks, so for and for machine learning algorithms. So I think I specified this on my on the meetup page, but you need a Gmail account for this, and having a GitHub and Quandl account is also preferable. If you want to look at the colab, the link to the GitHub page is here, or there rather. We'll be using Google Colab throughout extensively in Seattle TensorFlow because Google Colab has a built-in GPU, which will allow us to accelerate our convergences for our deep learning neural networks. So let's move over to the Colab environment. So we're going to be looking at a couple of different data sources. So and also we're going to first start by looking at how to import CSV files in Google Colab.
Could you help plug this in?
Oh, sure thing.
Sorry for the interruption.
So to download files onto Google Colab, it's pretty simple. You just run this these two lines of code, and then what you can do is it'll give this menu, and you can basically drag and drop whatever data you need. In this case, I'm going to use government data, which I got from this data.gov website on hourly electricity into it, and it basically uploads the data to the Colab. And then what we can do is we can unpack the data using pd.read CSV. And we can actually even print it out. So see, we have the now have the hourly electricity on our Google Colab now. So one of the reasons why we want to use pandas data frames is that they're very flexible. You can do a lot of data manipulations with them. So I should actually probably put the link to the pandas data, the cheat sheet, the pandas cheat sheet. So that's the link for anyone who is interested in having a look at that. You can do all kinds of things with that, which because it's far more flexible than NumPy arrays.
Sorry, where was the data again? The link for the data?
The link for the data, it's
I can Google it too. Yeah, I agree.
It's on GitHub, in your notebook.
Oh, okay.
yeah. So after we do that, one of the things which we'll want to do actually is we'll want to use a scalar.fit transform. And what that does is it standardizes, it reduces the data to a scale between 0 and 1. So this is immensely helpful for deep learning neural networks because it actually allows for faster convergence and lower error when it reaches convergence. You generally don't want to use a standard scalar unless your data conforms to a what's known as a standard normal distribution, which you might remember from high school. Because it will actually try to force the data to conform to a standard normal distribution. So it'll distort the data. So min-max scalar is generally preferable. And then most of the time when we get data, whether it's from a government source or whether it's from any other source, the data is oftentimes has missing values. So scikit-learn actually has a really cool library which you can use, which basically allows you to input the mean or input the median into the missing data columns, so that you can basically have, if you need 225 data points and your data set only has 222 complete data points, then you can just kind of fill in those 3 missing data points with what can be considered reasonable guesses. And also there is the dropna and fillna functions as well, which fillna basically fills any nan columns with zeros, and dropna can actually drop entire rows or drop entire data points from the data set entirely. And then one of the other things which you might want to consider as well, depending on whether you feel, based upon your domain knowledge, whether you feel it's the right course of action, is to Windsorize the data. And basically, Windsorization is where you take the data and get rid of any outliers in the data so that the values in the data are kind of normal in a sense. You don't have any weird outliers skewing your data and then skewing your deep learning neural network. This is the pandas.concatenate function, and what that does is it actually compresses multiple data sets into one single data set. So that's generally useful if you want to do multivariate prediction, where you are using 5 different data sets to, for example, predict values in a output data set. So if you're trying to predict future electricity prices, just as an example, then you can take these 5 other data sets and then squish them together and put it into your deep learning neural network, and it'll use that to predict future electricity prices. And the other thing which you also want to consider when you're putting your data into a machine learning or deep learning algorithm is actually instead of taking the values themselves. So, for example, electricity usage in the United States in a certain hour. What you instead would want, what might want to consider doing is actually taking the difference in the electricity prices hour by hour. So how the electricity consumption changes over time. And the reason is because if you take the derivative of the data, that is how the data is changing rather than the data itself, then you can basically, that actually makes it easier for deep learning neural networks to create models and make predictions based on those models than if you try to predict the actual discrete values. Generally you'll want to expand the number of the dimensionality of your data, especially if you are going to plug it into a recurrent neural network. So if you'll want to expand the dimensionality of the data if you're putting it into a recurrent neural network. And that's, I think, pretty much all I have. So this is for Seattle TensorFlow going forward. We'll probably in the next meeting go over, do a deeper, bigger lesson, so to speak, on unsupervised clustering, regression, and classification with vanilla DNNs. And then we will probably hold, after that, more advanced workshops on concepts such as probabilistic deep learning, recurrent neural networks, which are mainly good for making predictions using time series data sets. And we'll also be looking into how to do hyperparameter optimization using Sherpa. If anyone is interested in becoming co-organizer, they can email me at sabarnos@live.com. And if anyone would like to comment on what else we should be doing during these meetings, they can post comments on the Meetup account, or they can email me again at sabarnos.live.com. And yeah. So the reason why I scheduled it up till 12 is because I wasn't entirely sure how long this would go up till and how much time I'd need, so I made sure to give myself plenty of time so that we wouldn't go over, so to speak. Thank you for coming.
Thank you. Do you know if future meetings are going to be here in the same location, or vary?
We're trying to find locations in Seattle, but for that we would need to find someone who's willing to sponsor us and give us a space in Seattle. So,
Have you talked to the people at Google? They've got that big new campus right up at the south end of the lake.
yes, I'm attempting to communicate with them now, actually. And again, if anyone would like to be a co-organizer and help me find a space, or they know someone who can sponsor us and give us a space, that would be great.
So we're going to continue using like SciPy, or is it going to be actually, we'll be using TensorFlow?
We'll be using scikit-learn and SciPy for the pre-processing, which a lot of which you saw here. But for the deep learning itself, we'll be using solely TensorFlow.
The Keras, like 2.0 or the 1.0?
Probably the 2.0.
Do you think like writing the whole algorithm, or just use the libraries?
We're going to be writing an entire algorithm from doing the pre-processing to the data visualization.
What is the algorithm is like?
But we're going to use the TensorFlow Keras library to construct the neural network.
Okay.